very soon. All right, so let's finish this. And to allow chaining like this, the stream output operator is actually the nature of it is that it's what is it? Is it left to right or left to right associativity? I'm just thinking that what needs to happen if I want to display ret1, this needs to take place first. So this is left to right associativity. So this needs to take place first. The result of this expression, most likely, what I want as a result of this expression is a reference to Cout. Then I can continue with this piece, right? And I can continue with this piece. Now, if so, this piece supposed to return a reference to Cout. Then this piece supposed to return also a reference to Cout. Something like this. And then I can finish it with, doing this part. Oops. Doing something like this. So the result of this should be another reference to Cout. So I made a mistake. What I need to return from this operator is a reference to Cout. But I can do it very easily by simply changing the return value to this and then returning returning this so that I'm sorry, returning stream. Stream is my Cout inside this operator call. So something like that should work. Of course, I need to modify the declaration right here. It needs to become this. And if everything's okay, let's try to build this. So it says, so what it's unhappy about is that operator this overloaded function differs only in return type from rational operator ostream const rational.
What about your friend?
Oh yes. This is, thank you. This is where yet again I need to make sure that we keep our friend the same, so that everything is recognizable. And hopefully this is the problem. Thank you. I wasn't thinking about that. Syntax error, missing a semicolon someplace. Okay, and it's here. Yes, I forgot to add a semicolon here and maybe like a new line at the end. Okay, so this program supposed to create ret1, create ret2, compute ret1 plus ret2, create ret3 as a result, and display ret3, and then tell us whether what the result of the comparison ret2 to ret1 and so forth. So we should see some output, right? So let's hope that it builds and run it. And so it basically shows us that ret3 is 25 divided by 5, right? And then that ret1 equals ret2 is false. But finally, we can now essentially, instead of demonstrate, notice that this works, right? So this is exactly the same as this. So when you write something like this, but operators are overloaded, in reality, what is taking place? A function call is made. It's a member function of rational class, and it takes another rational as a parameter. So again, if we made this change, build it, run it, and so now it does the same thing but this time it does call operator based on the convenience syntax, right? So without much delay, we were able to overload plus, overload stream output operator, and overload the equality operator. So and we have it all pretty much on this single page. So now, arguably, if you do everything in one file and write it in line, it can be a little harder to comprehend. But here you can focus on individual functions, and of course, if you have a decent display resolution, you can show a lot of code on even one display. But if you have a computer with two displays, it's even better, right? So you can, it's a bit tedious. It's a bit tedious, no question about it. And it comes with a set of rules. So after this experimentation, we can switch back to our presentation to talk a little bit about this member versus non-member a little bit more, because we had the demonstration, but let's talk a little bit more about the rules also. Any other questions or thoughts before we take a break? So that should give you
the plus operator.
Yeah.
Does it have to be of type rational? Is that for creating a new? Could you if you just wanted to change an existing type? Could it
Absolutely. Or absolutely. What we could do? Yeah, let's do this too before the break. I could overload it as, for example, returning a double.
I'm done asking questions after that.
Yeah, but I mean, you see what I mean? You are in charge of what you want this to do. You could return a string, and if that's your choice, fine, do that. But typically you would expect it to actually produce another rational, because I mean, most people will probably expect this to work, right? Just say, if you're adding two rational numbers, you get rational 3, but eventually you can convert it to double, right? And we can do it right here, right? We can also say rational 3. Once we output it, we can also display. Remember, we already added 2 double. I think we added it to double, so we can convert it to double as well. Did we? 2 double? Or is this my fantasy? No, we probably never. No, actually, we added it. So let's try to build this. I see what happens. Syntax error. I messed up. Oh, too many of the operators here. Okay, and I probably need at least a space in between, something like that. All right. So yeah, so the result of this is 5. 25 divided by 5 is 5. We've converted to double. So that's okay. We're sort of like in control of what this is. I should have probably said, something like this, equals 5 to make things looking nice. All right, then. So there you go. So 25 divided by 5, of course, is a rational number, but we can convert it to double. The result comes out as this, very clean and neat. And then we can also use our other operators that are already defined. So, but not all of this operator overloading business, not all of it is just making our class behave nicely, like we just try to make it behave. Some of it is a pure necessity, and for example, assignment operator. We can discuss that. Assignment operators sometimes must be overloaded, not for the reason of being nice, but because we want to make our class safe. So let's discuss this after the break.